Hello students, welcome to another video on rotational motion. In this video, we continue practicing and working with torque in the moment of inertia of objects that are undergoing rotational motion. In this video, we're going to look at a cylinder that is rotating about the horizontal axis. So I hope you had time to go through this question. If you still want to, maybe you haven't gone through your notes, or maybe are new to this topic, you can just check the description. I'll leave a link to my introduction video. You can just check it out and then see if you can attempt this video before seeing the solution. Okay, so if you've done that, you can go right ahead and try to work it out. So here they're saying a cylinder of that radius is mounted on a horizontal axis coincident with the cylinder's axis. So basically what they're saying is, if this is the horizontal, then we're going to have a cylinder, and then for this cylinder, what is there is its horizontal axis is coinciding with the horizontal. So basically what we have is something like this. Now, the next thing that the question is saying is that you have a chord that is wound around the cylinder. So basically you have a chord that goes something like that, and then it goes all the way around the cylinder. So from there on, they're saying at one end of the chord, you have a mass that is hanging from there. So let's say this mass was initially there, something like that. Okay, now they're saying after being released, the mass drops 180 centimeters in 1.5 meters. So this mass, after being released, it drops all the way down a height of 180 centimeters. So basically we're saying the drop or the displacement it falls to is 1.8 meters. Okay, now if we look at what is there, here we have mg, and then here we have tension in the chord that is pulling up. But then when you come to the cylinder, the cylinder sees the tension here as the tangential force. So basically what I'm saying is what the tension in the string is literally a tangential force to the cylinder. Okay, now how do we work it out? Since the question is the first part of the question is asking us to find the moment of inertia of the cylinder, what we have to do then is we start from the cylinder itself. The equation that gives us the cylinder, that's for torque, the moment of inertia of the cylinder. Just generally, the moment of inertia is torque is equals to the moment of inertia multiplying the angular acceleration. And then from here, what we notice is, what you have to remember is, torque is also equal to force at a tangent times the radius. So again, we did point out that this force, which is a tangent to the cylinder, is actually the tension in the chord in this case. So then we have to say Ft, since Ft is equals to T, then we can say torque is equal to the tension times the radius. Now I have to say this is not always the case. So you just have to keep that in mind. If there was another object that was tied to another end, then the tension would have to get it by getting the difference between the two forces. So hopefully we're going to work out an example with that condition. So you guys will be able to see exactly what I mean there. Okay, so in this case, of course, when I equate this equation to this equation, as in I work out, I equate the right hand side. This now just implies that the tension times the radius is equal to the moment of inertia of the cylinder times the angular acceleration. This then means the tension is equals to the angular acceleration multiplying alpha over the radius. Now, remember what alpha is. So the tangential acceleration A, let's just label it as A, is equal to, you guys will have to remember these equations. I think we looked at them already. So I'll leave a link in the description if maybe you didn't see that video. So that's R alpha. So from here, I want to have the angular acceleration here. So this becomes as alpha is equals to AR. So when you substitute this, where there's alpha here, so the expression for tension now becomes T is equals to I over R, and then here you have A over R. Okay, so this is A, that's not a 9, so let me just write that properly. So this is A. So when we combine these, this becomes angular acceleration, moment of inertia, sorry, multiplying acceleration over R squared. Okay, so this is our tension. So we're going to keep this, and this is our equation 4. So now this was from the cylinder. Now what we're going to do is we're going to come down here. And then now we have to look at the forces that are working in the vertical axis for the mass. So for the mass, what you guys should observe is, let's choose down to be the direction of, since down is the direction of motion. So we're going to work with down to be positive. If that's the case, then mg is positive. Tension is going up, so it becomes negative. This is equal to ma. So here now I'm going to substitute my expression for tension in this equation. Let's say this is equation 5. So when you substitute our equation for T from equation 4, then this becomes mg minus moment of inertia A over R squared. This is equals to ma. So want to find the moment of inertia, we're going to make it the subject of the formula. Moves the other side, the ma comes this side. We now have mg minus ma is equal to I A over R squared. So we want to make R squared the subject of the, we're going to cross multiply the R squared, factor out the m this side. So the m comes out. When the R comes, also multiplies everything. So it comes this side. Now you have G minus A equal to IA. So divide both sides of the equation by A and bring the A inside here. Now you have m R squared. This side you're going to have G over A. The other side you're going to have 1. And then this is equals to the moment of inertia I. So basically from here, all you need is the acceleration, and you can easily work out find the moment of inertia. Okay, so now the question is, how do you find this acceleration? Now to find this acceleration, we have to use the second bit of the question. So the question tells us that this object falls through some height. So it falls through some height, let's say h, which is equal to 1.8 meters. It does this in a time of 1.5 seconds. So you can just go through the question if you didn't catch that bit. So let's make this a little bit bigger. So we see the saying, it falls through during this time through that height. So now with this this information, what we want to find is the acceleration making it fall. So we know the starting velocity is 0 since it's released from rest. So to work it out, we're going to use S is equals to UT plus half AT squared. So from here, the S, remember I took down to be positive, implying that since our S is a downward displacement, it's going to be positive as well. So this is going to be 1.8 is equals to our initial velocity is 0, so this term becomes 0. Then this is half our acceleration, that's what we want to find. Our t is given to us as 1.5, so this is squared. So the 2 multiplies this side, now have 1.8 times 2. This is equal to a 1.5 squared. Divide both sides by 1.5, we end up with 1.8 times 2 over 1.5 squared is equals to a. And then when you work out this, you see that acceleration is equals to 1.6. This is meters per second squared. So having found our acceleration, then we remember our expression for the moment of inertia. It was I, and this was equal to mr squared. And then this was multiplying g over a minus 1. So when you substitute, the mass of the object was given to us as 100 grams, and then the radius of the object was given as 24 centimeters. So this is basically just 0.24. in meters. And then G, of course, is 9.8. And then we found that our acceleration is 1.6 meters per second squared. This is also meters per second squared. So when you substitute, we have 0.1, that is the mass in kgs, which is 0.1 kgs. This is multiplying 0.24 squared. Then this is multiplying the 9.8 over the acceleration, 1.6. Then this is minus 1. So when you work this one out, you should be able to find the moment of inertia I as 0.0295 kgs. And then this is meter squared. So you can try it out just to see if that's the answer that we get. Okay. So once you get the moment of inertia, the second part of the question is asking for which is this part. So they're asking for the tension in the code. So for the tension, we're going to use an expression for the tension that we derived here on. So we had, we're going to use this part, tension. Let's see if that's okay. So I think this is better. We're going to use equation 4. Tension is equals to moment of inertia times acceleration over r squared. So we're going to use equation 4. So from equation 4, we see that we have tension is equals to moment of inertia times a over r squared. So the moment of inertia is 0.0295. So multiply this by 1.6, then divide this by the radius. So the radius was given to us as 0.24. So this is 0.24 squared. So when you do this, you should be able to get your tension as 0.82 Newton. So everything else is into the 3 sig except this, well, that's now 3 sig. So you can say yeah, it's basically the same, 0.82 newtons, or you can write it as 0.820 newtons if you want to do significant figures. Okay, so that is the tension. All right, so I hope you were able to follow. I kept this video very, very short. So yeah, if you found this helpful, you can just leave a like, or if you have any questions, you can comment them in the comment section below, and we'll be able to respond to you in the quickest possible time. All right, you guys, we'll see you in the next video.